Hey guys, welcome to the video for multiplying polynomials. We're still in Unit 1 and our essential question is what's the process we use to multiply polynomials? The long answer, short, is really just distribution. Okay, so let's review some vocabulary. We have monomial, and mono means one, so this is going to be one term. Binomial is going to be two terms, and trinomial is going to be three terms. Right? And these are all polynomials. All of these are polynomials, but those are the special cases. So there are many types of polynomials that we can multiply together. The first type is if we have a monomial times another monomial. So I'm going to go over some basic review really quick before we get into actually multiplying. So x plus x is 2x, right? But x times x, like I said in the last video, is going to be x squared. Okay, so let's talk about this, right? X squared and 2x are not the same thing, right? Because if x is 4, 4 plus 4 equals 8. But 4 times 4 equals 16. So these are definitely not the same thing. So it does matter what you do. Now, what are you allowed to add? You're only allowed to add like terms. So for example, 3x plus 3y, I can't add those. So this would be my final expression, right? Because I can't actually add them. Because I don't know what x is and I don't know what y is, so I can't just add them. I don't know. However, multiplication, you can pretty much multiply anything. So if I have 3x times 3y, I can multiply that. I'm allowed to do that. Now, let's go ahead and talk about this. X plus y. Again, can't add that, but if I have x times y, that's just going to be xy. I can't multiply them and mush them together and make a new variable, but I can just say x times y because that's what it means. So x plus y remains x plus y. X times y will just be xy, which still means x times y. So if I have 13x times y, that's going to be 13xy. Because that's what that's what I can multiply. So let's go ahead and go to number 1. This is all multiplication. 5 is being multiplied to x squared, and we're multiplying that by 3 times x. So this is all multiplication. 5 times 3, well, I can actually multiply those because those are like variables, right? So 5 and 3 are the same, so I can do 15. And then x squared times x, well, what is that? That's going to be x cubed. Actually, let's do blue. I like blue. Okay, so 15x cubed. That's what we have as our simplified thing. Because, why? Because 5 times x squared is x times x. So that's 5 times x. And then this is 3 times x. And I'm multiplying all of this together. Well, 5 times 3 is 15. And then I have x times x, which is x cubed. Whoops, I don't want to erase all those highlighters. Oh, no. Maybe I'll just go backwards. There we go. All right, number 2, negative 2m squared n squared p to the 5th times 6. Well, do I have any like items that I can multiply easily? Yeah, negative 2 can multiply to 6. Those are two things that I can multiply and make it simpler. That's going to give me negative 12. However, m squared can't multiply by anything else. It can't combine, so it just stays m squared. N squared is the same thing, and so is p squared. These all stay the same thing because you can't combine them with anything else. So there is a difference between combining like terms and then being able to multiply anything. All right, let's move on to single distribution, or a binomial times a monomial, or monomial times a binomial. What's a monomial? One term. A binomial is two terms. So something like number 1 we've seen before. And we just do single distribution because we're distributing only one term. I'm going to distribute the 5 to the x. 5 times x is going to be 5x. And then I have 5 times 6, which is going to be positive 30. Right, so I have those arrows there to show you what am I doing. And remember, distribution is the operation of multiplication. We are multiplying. All right, number 2. 5m plus 2 times m to the 5th. Well, what's different about this one? Instead of the m to the 5th being at the front, it's now in the back. But it doesn't still change the fact that we still have to distribute. So m to the 5th times 5m is going to be 5m to the 6th. because you have 5 m's being multiplied together, right? This is m times m times m times m times m. And then you have 5m over here. Well, if I mush that and multiply that all together, I have 5 times 6 of those m's. All right, the next part, I have m to the 5th times 2, which is going to just be positive 2m to the 5th. I'm going to go ahead and move this up here so we have some room for the next problem. All right, moving on to number 3. Okay, well, I have negative 3x times x minus 4. I'm still going to single distribute, so negative 3x times x is going to be negative 3x squared, because x times x is x squared. Remember, it's not 2x, x squared. Negative 3x times negative 4 is going to be positive 12x, because remember, there's an x here, so it's going to be 12x. And again, I'm sorry if I'm talking too fast, but you can always pause and you can always stop or go back in the video. So that's why I'm talking a little bit fast. We don't want the video to be too long. And if you're not taking notes, you are wrong. So make sure you are taking notes. All right, number 4 is a little bit different because now we have 2 variables involved. But that still doesn't change the fact that we're still multiplying and still distributing. So xy squared times x fifth y. Well, you're going to only be able to multiply things that are the same, right? So they can only be the same variable. So if I have x times x to the 5th, that's going to be x to the 6th. And then I have y squared times y, which is going to be y cubed, because I have 3 y's being multiplied together. Y times y times y. And then I have x fifth times x, which is x to the 6th. Okay, next over here, I'm going to distribute over there. I'm actually going to fix that because that arrow is way too high. There we go. All right, now I'm going to distribute over here. So I have x times x to the 6th, which is going to be x to the 7th. And then y squared times y cubed is really y to the 5th. All right, so we're just multiplying here like normal. So I still have x to the 6th times y cubed plus x to the 7th times y to the 5th. All right, moving on. All right, this is the page that gives us a lot of issues. I'm going to put a star on this page. It's an important page. Also, I'm never going to teach you something that you're not going to be tested over. So you're always going to be using these types of things. So I'm not teaching you just for no reason and just be like, oh, that's not going to be on the test. Like all of this is going to be what you're tested over. So make sure you understand how to do it. All right, double distribution. And this is a binomial times a binomial, and sometimes even more. So we'll talk about this. Number 1. Well, I have 2 sets of parentheses here, but let's talk. If this part was not here and all you had was a 3 in the front, what would you do? Well, you would distribute, right? You would multiply and distribute. Okay, well, what if this 3 wasn't here? You do the same thing. You're going to distribute the x. So this is why it's called double distribution. Instead of just distributing one term, now you're going to be distributing 2 things. So let's begin. X times x squared, or x times x is x squared. And then we have x times negative 4, which is negative 4x. So I've distributed one single term to 2 terms in the other one. And remember, you distribute to however many there are in those parentheses. Next, I'm going to have 3, because I'm done distributing the x. I have 3 times x, which is going to be positive 3x, and then 3 times negative 4, which is negative 12. Now, the reason why I'm doing the arrows at the bottom for that one is just because I don't want a bunch of arrows up here, right? It's going to be too many arrows, and I don't know what's going on. I'm also going to try to color code for you and distribute so that you can see where everything is coming from. Now, I have to talk about like terms. I have like terms, right? I have negative 4x, and I have positive 3x. Those are like terms, and that becomes negative x, or negative 1x. The x squared stays in the front, and then you have a negative 12. And that is my final answer. Now, what would this be? Well, this would be a second degree trinomial, so if I wanted to classify that. And most of the time when you're distributing or double distributing, you're going to have like terms. So always check for like terms. All right, number 2, x minus 5 times x plus 5. Same thing, you're going to double distribute. X times x is x squared, and x times 2 is plus 2x. So you distributed one term, now you're going to do the double, so which is the second one. Negative 5 times x is going to be negative 5x. Negative 5 times 2 is going to be negative 10. Always check for like terms. In this case, you do have some, 2x minus 5x. So that's going to give us negative 3x when we combine those. And then the negative 10 and the x squared stay the same. Oops, iPad is messing up. Let's go, iPad. There we go. All right, so we've done 2 so far. Moving on to number 3. Let me move this, make it smaller. All right, you're going to do the same thing. Now, this one looks a little bit different, and that's because you have a coefficient in front of your variable now, but you still treat it the same way. So we have 3x times 2x. That's going to be 6x squared, because x times x is x squared. And then we have 3x times negative 5, which is negative 15x. Then we have 1 times 2x, which is 2x. 1 times negative 5, which is negative 5. So again, you're just distributing each of those items, or each of those terms. And then next we have some like terms. We have, let's use purple like we have been. We have negative 15x plus 2x, which gives us negative 13x. And then we have 6x squared, and then minus 5. So those are going to stay the same. Now your like terms are not always going to be in the middle, but you will usually have like terms if you're double distributing. They just might be on like the outside. So it just depends. All right, number 4. 3x minus y times 2x minus 5. Again, looks a little scary, but you do the same thing you've been doing, and you know how to do that, which is double distribution. So we have 3x times 2x, which gives us 6x squared. Okay, so x times x is x squared. 3x times negative 5y is negative 15xy. Because you can't combine xy, but you can still multiply them, so it's going to be xy. And then I have negative y times 2x, which is negative 2xy. And then negative y times negative 5y is going to be positive, because a negative times a negative is a positive, 5y squared, because you have a y and then a y here. Okay. Also, if you ever run into the fact where you're like, well, I have 15xy and then 2yx, and you're like, those aren't like terms, but they are. They're just not in order, right? Because 5 times 3 is the same thing as 3 times 5. So they are like terms. They're just not ordered the same way. So it's not a big deal, and yes, they're like terms. And then here, do I have like terms? Yes, negative 15xy and negative 2xy. Those are like terms. And they combine to make negative 17xy. We have that there and that there because we can't combine this. Now you're like, well, that's not standard form. Okay, so you're never going to be asked for standard form if there's more than one variable involved. So if there's 2 variables involved, then this really is your standard form in quotes, right? So you're going to have a squared on both sides and then the mix of the 2 in the middle. And that's usually your standard form. So I'm going to go ahead and box this. All right, number 5. So this one's a little bit different. So this one's special, and we're going to talk about that. So the first instinct that people want to do is they're like, oh, well, this is x squared minus 1 squared, because I just want to put the 2 and distribute the exponent. However, that's incorrect, and I'll explain to you why it's incorrect. So you don't have to write this, but I would like you to watch to know why this is incorrect. So you think it's x, or people think it's x squared minus 1 squared, and let's test that theory out. So let's pretend, and let's even put x minus 1 squared down here. Let's pretend x is 5, right? Let's pretend that x is 5. So if x is 5, the correct way, right? So this is the way we have at the beginning. So let me actually switch these because this doesn't make any sense for this one to be first. Okay, so this is what we have right now. Okay, so this is exactly what we have right now, but now I'm going to replace the x with a 5. So I have, whoa, Whoa. iPad. Hello. Okay. I have 5 minus 1 squared then, if I replace the x with a 5. Now what do? Simplify. What's 5 minus 4? 4. Right? And what's 4 squared? 16, because 4 times 4 is 16. Now let's test it the other way. Let's see if the other way is correct. 5 squared minus 1 squared. Well, that equals 5 times 5, which is 25, and then 1 times 1, which is 1. So 25 minus 1 is what? 24. Are 16 and 24 the same thing? No, they're not the same thing. So that means that the red way is incorrect. So you're never going to distribute. Well, what does it mean to have something squared? If I have x squared, what does that mean? It means I have x times x. I have something times itself. So if I have x minus 1 squared, it means I have x minus 1 times itself. So for this one, you write it twice. Okay? Just think about that little exponent 2 telling you to write it twice. Double. All right, and then from here, you're going to go ahead and double distribute. So x times x is going to give me x squared. X times negative 1 is negative x, or negative 1x. Negative 1 times x is negative x. Oops, I forgot to use a different color. My bad. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Okay, checking for like terms, I have negative x minus x, which is going to give me negative 2x. I have x squared here, and then I have plus 1. So this is my simplified answer. Again, this is a second-degree trinomial. We've had a lot of second-degree trinomials if you haven't noticed, right? Number 1 had a second-degree trinomial. Number 2 had a second-degree trinomial. So those are relevant. Number 6, 4x plus 3 squared. What does that mean? We're going to write this twice. So just like the last one. So we're going to have 4x plus 3 times 4x plus 3. And I want you to give yourself a minute and try this one on your own and see if you got it. All right, so, sorry, I was going to go grab something. All right, so 4x times 4x is going to be 16x squared. Remember, you're multiplying. Okay, and then we have 4x times 3, which is 12x. Whoops, I'm using purple. That's been my joining color. I need to change these colors. So, yeah, 4x times 3 is going to be 12x. Let's do blue. All this needs to be blue. All right, cool. We're back on track now. Ugh, sorry, I'm trying to decide. Green. All right, 3 times 4x is going to be 12x. 3 times 3 is going to be positive 9. All right, again, you're going to look for some like terms. I have some, 12x and 12x. And that's going to give me 24x. Whoops, forgot to put the plus sign here. Plus 9. Perfect. All right, so that is in the simplest form because I cannot simplify it any further. Number 7, what are you going to do? You're going to write it twice because there's a square there. It means I have it times itself again, or it times itself. Okay, so 5m cubed times 5m cubed. That's where we're going to begin. That's going to give us 25m to the 6th because m cubed means I have 3 m's being multiplied, and m cubed means I have 3m being multiplied. So if I have m cubed and m cubed, I have 6 m's being multiplied. So it's going to be m to the 6th. 5m cubed times 4 is going to be plus 20m cubed. All right, next step. We have 4 times 5m cubed, which is still 20m cubed. Don't forget your variable. We tend to do that sometimes. 4 times 4 is going to be 16. Like terms, I have 20m cubed plus 20m cubed, which is going to give me 40m cubed. And then I have 25m to the 6 in the front, and then a 16 in the back. And I cannot simplify that any further, so that is my, oops, why did it do that? Oops. That is my simplified form because I cannot combine any other like terms. I need to shrink all of this. There. Okay. Notability is great, guys. If you have it, oh my gosh, it's so good. I'm going to shrink this one as well. Okay, number 8. So, what's different about this one? Well, now I have a binomial times a trinomial. So, what's different? Nothing. It just means that instead of distributing x to only 2 things, now I'm going to distribute it 3 times. And I'm going to distribute the 4 3 times as well. So, x times 3x squared is going to be 3x cubed. X times 5x is going to be 5x squared. And x times negative 1 is going to be negative x. Next, we have 4 times 3x squared, which is 12x squared. 4 times 5x is going to be 20x. And then 4 times negative 1 is negative 4. So hopefully we kind of understand like where all that stuff came from. We're just distributing, right? So instead of just distributing to a binomial, now we have a trinomial that we're distributing to. So it's just kind of one extra step. All right, let's look for like terms. Well, I have 5x squared, and I have 12x squared. So those are like terms. So I know, let's look. 3x cubed has no like terms. So I know I'm going to start that in the front. And I want to do this by standard form. So I am going to do this by the next highest exponent, which is 2. 5x squared plus 12x squared is 17x squared. But then I also notice that I have more like terms. I have negative x plus 20x. That's going to give me positive 19x. And then negative 4 has no like term, so that stays back there. So if you have a trinomial and you're multiplying it by a binomial, you might have 2 sets of like terms. Number 9, 5x minus 2 times 5x plus 2. Same thing as earlier. 5x times 5x, 25x squared. 5x times 2 plus 10x. Negative 2 times 5x is negative 10x. Negative 2 times 2 is negative 4. Well, what do you notice about our like terms here? Our like terms are the same number. We have positive 10x minus 10x. What does that equal? So the 2 answers I get the most are, well, it equals x. No, it equals 0. So let's look. If I have 10x and I take away 10x, what is that going to equal? 0x, right? So I have 0. Sometimes people are saying x. 10x take away 10x is x. So you're telling me 10 minus 10 is 1x? No. It equals 0. So you have no x's left. Which, what does that mean? It means it technically cancels. So you have 25x squared and then minus 4. Those cancel each other out. They don't matter anymore. All right, number 10. Jamie's building a rectangular patio with dimensions 5x minus 1 and 6x plus 2. Find the area of the patio. Okay, please pay attention that it said, or please notice that it said area. I'm not asking you to find the perimeter. For some reason, people get perimeter and area mixed up. And I get it, it's two words that you use and you toss around a lot. But area means you need to take your length times your width if we're talking about a rectangle. So let's draw a picture here. I have a rectangle. Oh, that wasn't a straight line, I don't think. All right, so we have a rectangle. It's saying that we're trying to build a patio and we're trying to find the area. And we know the dimensions are 5x minus 1 and 6x plus 2. Well, how do I find the area of a rectangle? Well, the area of a rectangle is length times width, right? Okay, well, let's multiply the length and the width together. We have 5x minus 1 times 6x plus 2. We're multiplying the length and the width. However, are we multiplying just negative 1 and 6x together? No. We're multiplying the entire length and width together. So you need parentheses. So make sure you have your parentheses. Okay, make sure you have your parentheses, and now you can do the math. So this problem, you just had to set it up, right? It didn't give it to you, it didn't show you, hey, do it. It had a word problem, but you know the math. We've been doing it over and over again. 5x times 6x is going to be 30x squared. 5x times 2 is 10x. Negative 1 times 6x is negative 6x. And then negative 1 times 2 is negative 2. Let's look for like terms. 10x minus 6x is going to be 4x. And then we have, oops, got the plus sign because it's positive. And then we have 30x squared in the front, and then minus 2 in the back. And that is our area. And you're like, that's not a number, that's not area. However, we don't know what x is. So if they gave us x, we could calculate the real area, but right now it's just an expression. So that is it for your notes for multiplying polynomials. Please feel free to ask any questions if you have any.